In today's class, I'm going to explain a new concept in bottom-up parsing, that is shift-reduce parser. And here the shift-reduce parsing with a stack. And initially we need to know what the shift-reduce parsing is. Before knowing to learning about what the shift-reduce parser is, and just I'm recalling what the handle pruning is. And what the definition of the handle pruning in the bottom-up parser? It is essentially a process of detecting handles and using them in reduction. And this process can be called as an handle pruning. And whatever the working principle that we implemented to construct a starting symbol from the given grammar, from the given input string, the overall process can be called as an handle pruning. What we done there, we just handle the substrings in a given string and we reduce it by the productions. That concept is about an handle pruning, right? And we know how to draw the table representations in the handle pruning. Just in one column taking the input buffer, input string, and we are calling that as a right sententional form. In the another column it is an handle, and the next column it is an reducing by the production. And by using these three columns, we are constructing the starting symbol of the given grammar by taking the input string. And what about shift reduce parser? What about shift reduce parser is? And before going to learn about what the problems of the shift reduce parsing with the stack, here we need to know what the definition of the shift reduce parsing is. And this, by using this shift reduce parser in bottom up parsing, we are constructing the parse trees. We are constructing the parse trees from leaves to root. And here also it works, the shift reduce parsing works with the on the same principle of bottom up parser. And here a shift reduce parser requires some following data structures. And what the data structures means, here we are using two data structures. One is an input buffer and the another one is a stack. These are the two most important data structures that we are using when implementing the technique like an shift reduce parsing technique. And what is an input buffer? Why we are using this input buffer means just for storing the input string. Just for storing the input string, we are using the input buffer. And how we are using this stack in the shift reduce parsing? This stack is useful for storing and accessing the both LHS and RHS of the rules. A production is in the format of A tends to beta, right? Means it consisting of both the LHS and the RHS of the production rule from the given grammar. So by using this stack, what we are doing here is we are storing and accessing the LHS and RHS of the rules. And now by knowing what the principle that we are using in the shift reduce parsing and what the data structures that are consisting of this shift reduce parsing, now we are going to learn about what the problems of the shift reduce parsing is. Here there are two most important problems. One is to locate the handles and another one is decide which production to use. So for example, if the variable A is having more than two production rules, more than two alternatives to choose, it it is difficult to choose the productions. It is difficult to choose an appropriate rule for finding an input string. So these are the two most important problems that we're having in shift reduce parsing with a stack. One, to locate a handle. How we're locating an handling with an substring. Handle by a substring and reducing it just by replacing its corresponding LHS on the RHS, replacing its corresponding LHS on the RHS. And how to decide which production to be used if we are having more than one production rules, more than two production rules, more than two alternatives for the same variable. So we are considering these two as an problems in the shift reduce parsing with a stack. And initially I defined what the working principle that we are implementing here. This is the concept under the bottom up parsing, right? So here in this technique also we are implementing the same principle of the bottom up parsing. That means constructing the parse tree from leaves to root just by using the reduction. And then we are implementing the handle pruning technique, right? Then we are implementing the handle pruning technique here in shift reduce parsing. And After knowing the two problems, then we need to learn the initial configuration of the shift reduce parsing. And as the initial configuration consisting of only two data structures, as already explained that, the two data structures are, one is an input buffer and the another one is a stack. Make a note of these two are the data structures of the shift reduce parser. And the parser performs the basic operation. See, we're having four operations. Let you see the slide that I shared to you all. And a shift reduce parser is a stack automaton, right? Because we are using the stack implementation here, that's why we are naming that the concept is with shift reduce parsing with the stack. And here we're performing four basic operations. What the four basic operations are? The first one is a shift operation, second is an reduce, and the third is an accept, and the fourth is an error. And what the shift operation is? By using the shift, what type of an operation that we are performing here? So by using this shift operation, we're moving of the symbols from the input buffer onto the stack, and whatever the action that we performed just by moving the symbols into the stack is nothing but an shift. And see, here we're having a syntax, next word is shifted onto the stack. See, I'm handling the substring in the given string. Whatever the string that I handle, that string is pushed into the stack. Just I'm pushing the substring into the stack, onto the stack. And here the second operation is about an reduce. Here, if the handle appears on the top of the stack, then the reduction of it by appropriate rule is done. What it means is the RHS of a rule is popped off and the LHS is pushed in. Make a note. The RHS of a rule is popped off, and the LHS is pushed in. So this action is called as an reduction. So we are calling it as an reduce action. This is the one of the another operation that we are performing here. And the next one is an accept. Accept. Here, if the stack contains the start symbol only and input buffer is empty at the same time, then that action is called as an accept. When accept state is obtained in the process of parsing, then it means a successful parsing is done. Successful parsing is done. Did you get what the accept of, how we're performing the accept operation? Here we're having a single line statement that stop parsing and report success. When we stop the parsing, here we're having a question. When to stop the parsing? If the stack contains the start symbol only and the input buffer is empty at the same time, then the action is called as an accept. And the accept state is obtained in the process of parsing, then it means a successful parsing is then done. When and successful parsing is done. So this operation can be performed at the time of successful parsing. And the last operation is an error operation. When we will perform, when we will use this error operation, means what the performance of the error operation is. A situation in which parser cannot either shift or reduce the symbols. Make a note of it. If you get a situation that when we are parsing the input string, at that time we cannot either shift or reduce the symbols, right? Then it contains it cannot even perform the accept action, so it is called as an error, right? So it is called as an error. And here in this slide I explained the four basic operations of the shift reduce parsing, and with these operations we are performing the action. With these operations, with these four basic operations, we are performing the action. By knowing what the definition of the shift reduce parser, and then after knowing what the data structures of the shift reduce parsers, and then after knowing that how many basic operations that the shift reduce parsing consisting of, only the four, what and what the shift is, what the reduce is, what the accept is, and what the error is. And up to now we understand the basic definition and the basic operations of shift reduce parsing. And how many data structures that the shift reduce parsing consisting of? Only two data structures. One is an input buffer and the other one is an stack, right? With these two we are implementing the stack. With these two data structures we are implementing the stack by parsing an input string, right? And there itself we are performing some actions based on the four based on these basic 4 operations. We are performing these 4 basic operations at the place of action there, right? Up to now, I think you all understand what the definition of shift reduce parser is and how many data structures that the shift reduce parsing consisting of, and what are the 4 most important basic operations for the shift reduce parsing, right? And here with the example, you can clearly understand the concept of shift reduce parsing. See here, all of you make a note that consider the given grammar. Make a note that what I am saying now. Consider the given grammar. See, here in the slide we are having the grammar. In the slide we are having the grammar. And by writing the grammar, just you give the sequence numbers of the each and every rule individually. Means expression is having 3 rules, right? You divide that, you write individually, not by putting or in a single line. Just write down like this, and just by giving the sequence numbers like this, 0 1 2 3 4 5 up to 9 we are having. From the given grammar we are having 9 production rules, right? Are you all able to see this? Please all of you see the slide and get understand what I am saying and get the concept of what the shift reduce parsing is by seeing this example. By learning with this example, you can clearly understand now, right? And here, consider the following grammar. Now you consider this grammar and give the sequence numbers of this grammar starts with a 0 sequence. And now construct the input string. Construct the input string by using the shift reduce parser. This is the input string here. ID minus num into ID, right? And now I am constructing, I am parsing the input string. I am parsing the input string by using the shift reduce parsing. Actually, from the basic knowledge uh, about the shift reduce parsing, how many data structures it consisting of? 2, right? One is in stack. See here, one is in stack, and what the another one? It is an input buffer. Just make a colon stack and next make another colon input. And here we're locating the handles. We're locating the handle. So another colon is for handle, and finally whatever the 4 basic operations that we're having in the shift reduce parsing, we're performing those operations just by using an action. Just by using an action means here we are showing that what type of an action we are performing. That means what type of an operation we are performing here. So put a colon like an action. See, we are having 4 columns. One the data structure stack, another the data structure input buffer, and the third one is about an handle, and the next fourth one is an action. And initially the stack is empty, so it consisting of an only dollar symbol. And now I am in the input buffer, I am storing my input string into the input buffer. Now my input buffer consisting of id minus num into id, right? Id minus num into id. No need to bother about what this x minus 2 into y. What this x minus 2, no need to bother about this. Just note down the input string. This is the given input string. You need to construct the parse tree for this, right? Id minus num into id is the input string that you stored in an input buffer. Initially, we are not handling any type of an substrings in the given string. Just it is a none. And starting from the action now, we need to shift. We need to shift the substring by handling the substring. To handle the substring, we need to shift. We need to perform the operation shift. That means we are pushing this id onto the stack. We are pushing this id onto the stack by performing the action shift, because initially stack is empty, right? Initially stack is empty, and now we are performing the operation shift. By this operation, this id is pushed onto the stack, right? Now nothing we handle here. Now see here, in step number 2, we handle what we handle. Number 8 comma 1, what the 8 is, from the given grammar, factor tends to id is the sequence number 8. Factor tends to id is the sequence number 8, right? So 8. For why we are using this one is, our our intention to generate this input string is to get the starting symbol of the given grammar, right? To get the starting symbol of the given grammar. by shifting this id onto the stack and replacing it by the LHS of the production rules, replacing this terminal with the LHS of the production rules, I need to get one. What the one expression? I need to get one expression. So just I am placing comma 1 here, comma 1 here. This F tends to, this factor tends to id is the 8th production. Now I am reducing this 8, reducing this 8. That means id with, I am replacing, I replace that the RHS of the production rule with an LHS variable, right? Factor tends to ID. See all of you, factor tends to ID. In the place of ID, just a replaced factor, right? And where it is an 8th rule in the given grammar, where it is an 8th rule. Now I need to reduce that 8 into 6. Why? Because term tends to factor is the another rule we are having from the given grammar. So I am reducing this to term. Factor is replaced with an term. Now I am reducing this 6 with an 3. What the 3 is? Expression tends to term, right? Means in the place of term I am replacing with an expression. Did you get? Up to now, initially we just perform an operation shift. Just we shift, by performing an operation just we shift an id onto the buffer, and now we are replacing the left hand side of the variables in the place of this terminal one by one by performing the reduce operation, right? And here we get the expression. Now what I need to shift now without handling anything. See, shift minus, and expression minus, this type of rule we are not having in the production, we are not having in the given grammar. So again I am performing the operation shift. I am shifting num. Now my stack contains expression minus num. If I replace the terminal with the variables, then I can get expression minus term, where here we are having the rule number 2. So to get this rule 2, I am performing and reduce operation. See here, reduce. This factor tends to number is the 7th rule, right? In the place of num, replace factor and reduce this factor by 6. 6 in the sense term tends to factor. Now in the place of this factor, just replace it by the term. And here see, expression minus term. Expression minus term. Actually we are having expression minus term is the rule for second rule, where expression tends to expression minus term. But here we are not reducing with the, here we are not reducing expression minus term with an expression. What we are doing here is, again we are shifting the remaining input string from the input buffer. See here, we are not handling anything now, just we are shifting. Shift id, again shift id. Now the total input string in the input buffer was consumed. Nothing is there to shift, nothing is there to perform from the input buffer. Now by performing the actions here, we are reducing this from the stack. See how F tends to id is the 8th production, right? So reduce this, just replace id, replace factor in the place of this id, right? And reduce this 8 by, reduce this 8 by 4. What the fourth rule is? Term tends to term into factor, right? And again term into factor, where it is having term into factor is having the fourth rule. This is 4, and reduce the 4 to 2. Reduce this 4 to 2. Just term into factor is replaced with an term, and this expression minus term is an second rule from the given grammar, and expression minus term is directly defining with the variable on the left hand side, that is an expression, and where expression is deriving from the goal, where goal is the starting symbol of the given grammar, right? Is it clear? So our starting symbol from the given grammar is an goal. We reached the We reached the starting symbol. Then nothing is there to handle, accept. Nothing is there to handle. Then finally we conclude this with an accept. That means successful. And see, one see here, don't be confused here what the 8, what the 6, what the 3, all these. Just it is for our indication that we handle 8 and we are, that means we are handling 8 and we are reducing this 8 with 6. We handle 6, that is we are reducing this 6 with an third rule. 8th rule, 6th rule, third rule. And here this is not an 5. Make it as an 4, 8, 4 and 4, 4. It is not 5. 8, 4 and 4, 4. All of you make a note of this. Right? And after reducing the 3, there is nothing is there to handle. So shift and shift. And now we're having 7, where 7 is the factor tends to num. Now I am reducing this 7 with an 6th reduction rule. And nothing is there to reduce. So none. None. That means here nothing is there to handle. So none, where shift, we perform the shift operation. And here this 8 is reduced with an 4. This 4 is reduced with an 2. And this 2 is reduced with an 0. Where 0 is the starting symbol of the given grammar. So nothing is there to handle. Right? We are not handling these. We are handling only the 8, 6, 3. We are handling these and we are reducing this. Now I wrote here 8. What it means? I am reducing this 8 with 6. Now reduce 6 means I am reducing this 6 with 3. Right? After reducing, nothing is there. What this 1, 1, 1, what this 3, 3, and what this 4, 4, and what this 3, 1 means. See here, from the given grammar, I pushed onto the stack, right? By using these actions, I pushed onto the stack. I pushed my inputs onto the stack, right? And here, by pushing the ID onto the stack, this ID is replaced by some variables. Finally, I need an variable like an expression. To get the variable like an expression, I am just performing the operation like an reduce, then I will get the variable like an expression. This expression is an rule number 1, right? So I need an expression at the starting itself. So comma 1, comma 1, comma 1. Right? After getting the 1, after getting the expression, then it changed to 3, right? 3 means now what I need, see here, what the third rule is term. To get the term from after pushing the num onto the stack, and now my top of the stack is a num, right? Now I am replacing the variables in the place of this terminal. So what the correct terminal I need, what the correct appropriate terminal, non-terminal that I need an term. Term is the variable here. So where it is? In the third rule, right? So that's why I'm putting here 3, 3, 3, because with this rule, with the expression minus term, there itself I get the 3, because term is an third rule. See here, expression tends to term is an third rule. And after performing the shift operation, now at ID, now I am replacing the terminal ID with the variables. What the variable that I need here? 4. What the fourth one is? Term tends to term into factor. Term tends to term into factor is the fourth one. So 4, 4. We need to write 4, 4. And in the place of this term into factor, what I need? Term. Term is an third rule here. So 3. And in the place of this expression minus term, what I need an expression. So this is an first one. So 1. Right? Did you get how we are writing the numbers, the production rule numbers at the handle, at the column of handle? If you get confused by writing the handle with the numbers, just leave it. No need to write the column handle. Just with the stack, with the input buffer and the actions, you can represent the tree. This is the stack implementation in shift reduce parsing. In the concept of shift reduce parsing, with the stack, we just parse the input string and finally we get success. We get success by writing an operation accept. And here finally we use 5 shifts and 9 reduces and 1 accept. Right. I think you all understand how the parsing of the input string is done by using the data structures. See this slide. Here I remove the column handle only with the 2 data structures stack and input and the actions that are performed by using the basic operations. This table consisting of only the 3 columns, one with an stack and another with an input buffer, and finally what the actions that we performed by using the 4 basic operations. And here we're having the corresponding parse tree structure for this implementation, whatever the input string that we parsed, and for that input string here the corresponding parse tree representation is there. And what x minus 2 into y is, in the place of ids I can use an variable. So in one id I use an x and in another id I use an y. In the place of num I can use any type of a numerical constants. Here I take an 2. So goal expression minus term, and term into fact, expression is directly within term is directly within factorial, and where it is the factorial is an id. Here the id is represented with an x, and factorial is directly having the rule num with n2, and into the fact is directly factorial is having a rule id, and id with an variable y. Right, this is the corresponding parse tree for this parsed input string by using the stack. Right, is it clear all of you? Where it is very small concept, there are no logics here and nothing syntaxes to be followed when to construct the shift reduce parsings or to construct the handle pruning. There are no syntaxes or rules or any type of an algorithms there and here. Just by taking an input string as by following the working principle of the bottom up parsing, that is constructing the parse tree from leaves to root, we are implementing this, we are constructing this. Right, is it clear all of you? All of you make a note of these 2 representations, and this is the given grammar, and from this grammar we are representing or we are parsing the input string by using the data structures and by performing an handle along with an action. And after knowing the concept of what the shift reduce parsing is and knowing how to do the how to parse the input string with the stack, and here we're having another concept, that is an conflicts during shift reduce parsing. Conflicts during shift reduce parsing. See, in each and every phase itself, we already known some commonly occurring errors. We known some commonly occurring errors. So after understanding the concept of shift reduce parsing, here what the commonly occurring errors that we can find out means some conflicts during the shift reduce parsing. What those conflicts means, here we're having mainly 2 conflicts. One is a shift reduce and other one is an reduce. What the shift reduce is, when it occurs means it occurs in a state that requests both a shift action and a reduce action. It requests both a shift action and a reduce action. And when this reduce conflict will occur, this will occur in a state that requests 2 or more different actions. 2 or more different actions. That means 2 or more different reduce actions at one place, at one entry. Then we can get this type of an conflict, right? These are the commonly occurring errors. We can call them as an errors, or we can also call them as an conflicts. We can easily find out that because each and every phase we're having some commonly occurring errors. So by default, we can check those errors and we can rectify there itself, and then we'll go for the further step, right? And here, see the example here. The example considering with an grammar, what the grammar is here, statement tends to if expression then statement, or if expression then statement else statement, or other, or any other statement, right? This is the given grammar. From this given grammar, how we are defining which type of an conflict it is, how we are uh, concluding that by seeing the given grammar which type of an conflict it is. See, from the example we can tell whether it is an handle. If the stack is if then statement, if then statement, and the input is else, then if you get this, if you get such type of stack and if you get such type of an input, right, then we can conclude with an shift reduce conflict. Then we can conclude such type of conflicts with an shift reduce conflicts, right? And from the given grammar, here we're having a grammar like this. My stack is with, my top of the stack is with if then statement, and my input is an else, right? And if I want to shift or if I want to reduce, what to do? What to do? That means in the same, and in the same entry, we're having both operations, both actions to be performed. Then we can get such type of an conflicts. So here we're calling them as an conflicts during shift reduce parsing. A conflicts during shift reduce parsing. This is a simple concept. Just by knowing what type of an conflicts that can occur when we're performing this type of an techniques, or we can call them as an errors, default errors. Default errors from the parsing table itself, we can get such type of an errors like shift reduce or reduce, like these two are the most important conflicts that can occur in the bottom up parsings. Why? Because here we are implementing the LR parsing technique. LR parsing technique. In next class, I will explain what the LR parsing technique. There at the last, we need to construct the parsing table. In the parsing table itself, we can we will get some entries like this. Means when I'm reading a non-terminal with the terminal, in that cell I'm having two conflicts. That means two actions to be performed. Either it may be shift or either it may be in reduce, or directly it may be both reduce and reduce. So at that time I can conclude that here at the entry of move the non-terminal with the terminal, I am getting this type of an conflict. So here such type of whatever the grammar we're doing for constructing the, were taken for constructing the LR parsing. So here such type of grammars are not suitable for constructing this type of an technique. Just by concluding with these statements, we are finding out these conflicts, right? And here from the starting of the class itself, I'm saying that whatever the grammar, the context free grammar that we are specifying here, it should be an unambiguous grammar. It should not be an ambiguous grammar. If the grammar is an ambiguous, then we'll get such type of an conflicts like shift reduce or reduce. So choosing of the grammars is most important when we are constructing and parsing techniques. In the next class, I will explain a most important concept, that is LR parsing technique. And after knowing, after understanding the construction of LR parsing technique, then we will go the further categorized, subcategorized parsing techniques in the LR.